Hello everyone, today we will learn the very basic concept of heat conduction. In this class, we will learn the Fourier's law, which is known as, the very basic equation for heat conduction. So we will learn the Fourier's law, and then we will learn what are the assumptions made in case of, Fourier's law. And then, we will learn the thermal conductivity. What is thermal conductivity and what are the units of this particular property. And finally we will learn the thermal resistance, how it is analogous to the resistance of electrical system. So without spending time, let us start the class. So as we said, this is conduction. So we will learn the Fourier's law. Fourier's law of conduction. As per the Fourier's law, the heat conduction is depending on some parameters. Okay, the parameters are the area and thickness, temperature difference. So these are some parameters on which the rate of heat transfer is depending on. So let us write on which parameters this rate of heat flow is depending on. So as per the this Fourier's law, rate of heat flow is depending on some parameters like area, okay, and it is depending on temperature difference, okay, and it is also depending on the thickness of the solid. Okay, so let us draw one very basic solid material through which the conduction is taking place. So if we draw okay, clear? So through this heat flow will take place, okay, and here it is suppose temperature 1, here it is temperature 2, okay, that side, and thickness is let us consider it is dx, okay, and this area is area is A, okay. So as per the Fourier's law, the heat conduction, that is rate of heat flow, is depending on area, temperature difference, and the thickness through which the heat flow will take place. So as per the law, this Q is directly proportional to the area. Okay, that means as per this Fourier's law, this Q is directly proportional to this particular area. Okay, and again this Q is directly proportional to the temperature difference T dt. So suppose one side this is temperature T1, another side it is T2. Clear? So depending on the temperature difference, temperature change, this Q will change. Okay, so that means this Q is directly proportional to the dt. So directly proportional to the dt. Okay, and next is that this rate of heat flow Q through the conduction is inversely proportional to the thickness. Clear? That means larger the thickness of the solid material, lower would be the heat rate. Okay, and smaller the thickness, larger will be the heat flow. So this Q is indirectly proportional to the thickness of this particular solid. Clear? So combining all these, relation, we have Q varies with A dot dt divided by dx. This equation will become, Q equals to one constant will bring A dot dt by dx. Okay, so finally we have got the equation equals to, so finally we have got the heat conduction equation where the rate of heat flow equals to K into A into dt by dx. Okay, so A is, the area which is perpendicular to the direction of the heat flow, and dt is the temperature difference, dx is the, thickness, and K is the constant. Okay, and here this K will be known as, so here this K will be known as, thermal conductivity. Okay, so in this way we find out the equation of heat flow rate through the conduction by using the Fourier's law. Okay, so finally we have got the Q equals to K dot A dt by dx, where K is, the thermal conductivity of the material. So here, the unit of Q will be watt. Okay, and area unit will be, meter square, and dt unit will be, centigrade or Kelvin. We have dx, of which the unit is, meter. So if we summarize this Fourier's law, we know that, the heat conduction takes place in such a way that the rate of heat flow will depend on some parameters. Okay, and as per the Fourier's law, this Q is directly proportional to the area. It is also directly proportional to the temperature difference, and it is inversely proportional to the thickness of the solid. And there are some assumptions which are made in case of Fourier's law. So now I am writing the assumptions which are made for Fourier's law, and these assumptions are steady state condition. That heat flow will be not unsteady, the heat flow will be steady state. And next point is heat flow. That heat flow will be unidirectional. That means the conduction heat transfer will take place in one direction only. The third assumption is the temperature gradient. The temperature gradient is constant. Okay, and the temperature profile will be linear. Okay, so these are the three number of assumptions, and the fourth number will be the solid will be homogeneous and isotropic. Number 5 will be no internal heat generation. Okay, so these are the some assumptions which are made in case of Fourier's law. The first one is the condition must be steady state. Okay, that means the temperature will not change with respect to time. And second condition, it is the unidirectional heat flow. That means the heat flow will always occur in one direction only. In the third one, the temperature gradient. The temperature gradient is constant. At the same time, the temperature profile will remain linear. Okay, and the materials through which heat transfer is going on, that material will be the homogeneous and isotropic. Isotropic means the thermal conductivity will be same in all direction. The last assumptions made in this Fourier's law is no internal heat generation. So we should consider that there is no heat generation inside that particular solid. So these are the assumptions which are made in case of Fourier's law. The next point of discussion is the thermal conductivity. As per the Fourier's law, we have found out that thermal conductivity is a constant. So for different material, this property will change. So here the thermal conductivity, which is denoted by K, is the property of the material through which heat transfer will take place. Clear? So we know that that K will be obtained by using the equation of heat conduction. Clear? So as per the Fourier's law, the heat conduction equation is Q equals to Ka dt by dx. Okay, so from this equation we can find out K equals to Q by A dx by dt. Okay, so here we can find out this K equals to Q by A dx by dt. Clear? And using this equation, K will be 1 when Q equals to 1, area equals to 1, dx equals to 1. Okay, so when the values of all the parameters are unit, then the K will have the unit value. And using this equation we can also find out the unit of K. So unit of K will be so we can find out the unit of K by substituting the unit of all the parameters. Okay, so we know that unit of Q equals to watt, unit of area equals to meter square, unit of thickness dx equals to meter, and unit of temperature difference equals to degree centigrade or K. Let us take K. Okay, so finally we have unit of K equals to W by mk. Okay, so this is the unit of K. Okay, so finally we have got the unit of K equals to W divided by meter Kelvin. So this thermal conductivity is a property of the materials through which heat conduction will take place. So for example, if we consider different materials like aluminium, silver, copper, iron, okay, so all the materials will have their different value of K. So K can be defined as the Q per unit area and per unit temperature gradient. Clear? So the Q, which is per unit area and per unit temperature gradient. Okay, so thermal conductivity is defined as the heat conducted through the unit area of the solid when the temperature gradient is also unit. The last point of our discussion is the thermal resistance. Thermal resistance, which is denoted by RTH. We know that the flow of heat and the flow of electricity are analogous. Clear? That means the way the electricity flow will take place, in the same way the flow of heat transfer will take place. So using the analogy of this both system, we can find out thermal resistance. So as per the Ohm's law, we can find out the relation between the electric current, potential difference, and the resistance. Okay, so as per the Ohm's law, we find out current which is denoted by I equals to potential difference which is denoted by dV divided by resistance. Okay, so as per the Ohm's law, we can find out the relation between current, potential difference, and the resistance. So using the same analogy, we can find out the thermal resistance. Clear? So we know that heat flow Q equals to temperature difference which is dt. We know that this is equals to dx by Ka. Clear? So this equation is obtained using Q equals to Ka dt by. From here we can find out Q equals to dt by dx divided by Ka. So using this particular equation, we can find out the heat flow Q equals to temperature difference by dx by Ka. And here this is termed as thermal resistance. Okay, so we have found out the analogy between electric current and the heat flow. Finally, we have got Q equals to temperature difference by R, TH, thermal resistance. Okay, so from this equation we have the concept of thermal resistance, which is equal to the dx by Ka. So this dx by K is known as thermal resistance, which is also denoted by RTH. Clear? So we have determined the concept of thermal resistance using the analogy between electric current and the heat flow. So since we have understood what is thermal resistance, therefore we can also calculate the unit of thermal resistance. Clear? So using the equation of thermal resistance, using the expression of thermal resistance, we can easily find out the unit of thermal resistance. So to find out the thermal resistance, we have we know that thermal resistance equals to dx by Ka. Clear? So if we substitute the unit of all the parameters, we can find out the unit of thermal resistance. So here let us put the unit of the parameters. So dx parameter is meter, K equals to W meter by K, and A equals to meter square. So we can find out one. So the unit of thermal resistance will become K divided by a watt. Okay, so finally we have found out the unit of thermal resistance equals to K by W. Okay, so K by Kelvin by watt. So Kelvin by watt is the unit of thermal resistance in SI unit. So in this class of basic concept of conduction, we have learned what is the basic equation of thermal conduction, and how assumptions are made in case of Fourier's law. We have also found out the concept of thermal conductivity, and what is the unit of thermal conductivity we have calculated. Finally, we have understood the concept of thermal resistance, how this thermal resistance is having analogy with the resistance of electric system. Finally, we have got the unit of thermal resistance. I hope that you all have understood this basic concept of heat conduction, and at the same time you can remember the concept of thermal conductivity and thermal resistance, including the units of all these two parameters. Thank you so much. I hope that you have enjoyed the class. I hope that in our upcoming classes we'll learn many new topics, different topics which are linked to GATE examination also. So keep watching the classes, the videos, so that you can learn the basics of mechanical engineering, basics of different subjects. At the same time, you can also learn concepts by which we can solve different problems, different numericals which are connected to the GATE examination.